Welcome. I've got the comments going on the side, so if you have anything to say as I go along, please feel free to shoot them. I will try and keep an eye as much as I can. So yeah, my name is Akanksha Malik, and I'm going to be doing a talk on Azure Machine Learning Studio and about zero code solutions. So it's not going to be a very in-depth codey technical talk. It's going to be a very high level kind of a how do we do things without coding in this day and age. So without further ado, let me move my slides to the next one and talk a little bit about me. It's my favorite topic, but that's the most Irish photo I can find of myself. So for those of you who don't know me and we're trying to figure out what the accent is, it's a weird mix of different things now, but it's predominantly an Irish accent. As I studied in Ireland and I lived there until I graduated college, and I studied financial maths and actuarial science. And as I was saying earlier, I moved to Melbourne and I found myself in a data science role. And that's kind of how this whole new world started for me, where I was like, okay, I'm doing data science. Data science, I think, has something to do with AI. So I started looking into AI, found it was a lot bigger of a world than I expected it to be, and then started drilling into different things. Machine learning was something I kind of was just fascinated by. I heard little bits about it, tried a few different things, and here I am now doing presentations on the things I've learned. It's just the easiest way for me to kind of continuously learn is by forcing myself to do presentations on the things I'm learning. So that's kind of why I'm here. And just as an FYI, I am in Melbourne and the pollen count is ridiculous. So if I start sniffling halfway through, it's the hay fever and not corona or anything like that. But yeah, please bear with me. And bar that, let's actually go straight into our demo. Sorry, not our demo, the rest of the introduction of the slides. So today's agenda. My agenda today is just essentially, I want to be able to create a model with absolutely no code involved, and how that is enabling, so the whole product of Azure Machine Learning, how it's enabling people with various skill levels, whether you're someone who has no coding abilities, great, come along, you should be able to do AI and machine learning, or whether it's someone who's a data scientist and has done PhDs in the field, and how it's enabling them to actually make the most of their time and be really efficient with how they're building their models. So that's kind of what the aim for today is. If you leave the next 40 minutes with an idea of, hey, if I wanted to, I kind of know how I could go about creating a model, I'll be really, really happy. And if you actually do go create a model, please let me know. It makes me really happy. So just talking about AI in the market in general, it's everywhere, right? All the buzzwords, AI systems, the object detections that are happening, bots, knowledge mining. If you talk to someone who is like a CIO or a CFO or anyone in the C-suite, they're obsessed with the idea of it. They're like, yes, we want our company to have AI because it's cool and future thinking. But no one really kind of grasps exactly what it is. And that's where that little shortfall falls through. So it's important that it's really, really big in the market, but what does it actually mean and how does it work to make sure you have that distinguishing features in there? Everyone wants it, but there's a lot of challenges with adoption of AI. So all these businesses and all these business people are like, yes, bring it to us. But then they don't realize how hard it can be. Or even if they do adopt it, then they kind of get stalled with, okay, they've maybe started using AI, but then they don't know how to make the most of it. And it's kind of predominantly a challenge based on the people. It's really hard to find data scientists and the people who can actually do the work that you need them to do. And that kind of stems as well from the fact that it's such a diverse topic, data science and AI and ML. If you look at the skills and stuff that you need, if I look at my skills, I usually use Python, but there's also people I know who only use R. That's immediately just a split in the fork of what the skill level is. If you've hired someone who's only used Python and built all of your procedures with Python, you can't hire someone that only has R skills to come in and help you out. You need to find another Python person. So as much as everyone wants to be a data scientist these days, there's still a really big shortage of the people that we need to be able to do the work. And then it goes into the processes. Processes can be so vast and so big. Setting up a environment for data science or any data projects can take time. It's just really menial. I mean, I've been on client projects before where it was a 2-week project, and I think it took me a week to actually just get access and set up on the whole environment. So process can be a little bit tough, and that's an adoption problem, because if you can't scale up really quickly, people lose interest, businesses lose interest. I'm like, why will they be willing to spend money for you to just set things up and not see any actual results. And then the technology itself. It's scary the amount of data that is needed at times to do these things, but then also that means at the same time you need to be able to make sure that your data is secure. All your models are secure, everything with the architecture, security, and being able to scale it. So if you're an individual person, right? I've created machine learning models on products that are just like on data that's 50,000 rows that sits on an Excel sheet somewhere on my laptop. That's great. But when you're looking at a big enterprise business, you need to be able to scale that across the business, which could be millions and millions of rows or terabytes of data. How does your architecture manage that? Where is that going to be stored? Is that going to be safe? These are all really, really big problems that the industry is facing at the moment. So with that in mind, let's talk about democratic. I can never say this word. It's like my favorite word across the whole thing. So democratizing AI. And this is where Azure Machine Learning Studio has come in a little bit. There's so many challenges to adoption and stuff that the people problem. We need people who really have specific skills. Creating products like this, which are zero code, it removes that problem because you don't necessarily have to have all these really specialized skills anymore. It's kind of for everyone. And that's the whole kind of ideal world that we're aiming towards, is the fact that everyone should be able to use it. I have a ton of data that exists in the world. I can leverage it at some level just because I have a few skills that I've developed. But everybody across the world, 7 billion people, have data associated to them. And it shouldn't be gatekept, that ability to use it and leverage it, just behind people who've been able to do maths or have the time to go do study and create models for their things. It just makes it easier and involves everyone in the conversation. So that's why I love talking about all these zero code solutions and stuff, just because it brings everyone into the conversation. So with that, let's actually look at Azure Machine Learning Studio as a whole. Who does it offer to? What does it offer? So they've got three main products within the studio, and I'll explain who it works the best for. So you could have someone who is absolutely no code and all the way to a code first level, and someone with no machine learning understanding at all to someone who's a machine learning expert. And notebooks and SDKs are a product that it offers. And those are for people predominantly who know exactly what they want to do. They know how to code. They know what libraries they want. They know what their data is. They can start going in, doing all their analysis, transformations, and pipelines, and testing and training stuff, and actually create their own models really, really specifically. So those exist, and those are there for those people who know what they want to do with the notebooks. But then on the complete opposite end of that spectrum, we also have AutoML, which is another feature of Azure Machine Learning Studio. And that's kind of for people who have absolutely no coding abilities and don't necessarily want to spend time trying to learn how to code because they have other things to be doing. And for someone who doesn't necessarily understand machine learning or wants to spend time figuring out what is a training pipeline or what's a testing pipeline, they just know that they have data in front of them that can be smarter and it can be leveraged. And that's the product. But it's not just for those people. It's also for the data scientists who use notebooks. It just reduces the amount of time that you have to go individually figuring out what's the best parameter or what's the best model for you. If you just run AutoML, it'll tell you, hey, these are the best kind of models I found. And then you can go take those away and actually really, really precision test those and make the accuracy a lot better on those. And somewhere in the middle of the two is the last product, which is Designer. And Designer is a drag and drop visual interface that they've created for machine learning. So there's no code involved because it's all drag and drop, but there is a lot more machine learning understanding that's needed for Designer, because you do still need to be able to understand how a machine learning pipeline looks. That you have your data, you need to clean your data, then you need to do your splits of training and testing data, actually put in the correct model that you want to assign to it. Sorry about that pop-up, thought I'd X'd out everything. And how to actually go train the model afterwards and what do you do with it. So there is a lot more machine learning expertise involved with Designer. So it's again that little midway for the people of, hey, you don't have to code, but you know what happens in machine learning, off you go. If you don't want any of that, there's AutoML, and then there's notebooks, which again are just for the classic scenario that you're used to hearing about data scientists who know exactly what they want to do with Python and their libraries. So today we're going to be focusing on Designer and AutoML as the no-code products that we have. So with that, what's my data? What are we going to be using and understanding? So these are kind of classic examples that exist in the market, or if you listen to anyone do demonstrations, it's just because the data is really, really big and really readily available, and it's easy to understand. So I've got a New York taxi data set. So if the world goes back to normal once these vaccines actually work, I might go to New York and I might want to go get a taxi. And America is just filled with all these tipping systems. I'm like, how much should I be tipping? So what I'm going to be using the New York taxi data set is to be able to predict how much you should be tipping based on fares and other details about a taxi ride. And also, we've also got another data set, which is the used car database. And so ton of data, different parts of the cars. Okay, if it's a four-wheel car, if it's got X amount of miles on it, all these different bits, how much should that car cost me? What is the fair value of that car? So those are my two data sets, and that's the machine learning I'm going to be doing on them. And with that, let's jump into a demo. So what we're going to go through is exactly how you would set up those two machine learning pipelines without using any code in a fairly short amount of time, and actually be able to use those models that you have created. But also, this is just a very high-level overview so that you kind of walk away with an idea of how you would do it, not necessarily exactly the step-by-step version. So whenever you're trying to do anything with Azure, at least, your first place, your favorite place that should be is your portal home. And to find your machine learning resources, you can search for machine learning. It'll pop straight up for me because I search it all the time. And once you do, you just need to create your workspace. And they've made this really, really straightforward now. All you really need is subscription. And after that, you can create a new resource group from the setup page itself. I'm just going to call this test for now. And give it a workspace name, SAM, let's call it that. And what this does is automatically it creates a storage account, a key vault, application insights alongside your machine learning resources. You can also create a container registry, but you don't necessarily need one unless you're doing something specific. And that's it. Off you go, you just hit create at the end of this, and it'll create a machine learning workspace for you. And that workspace, let me just go back to a workspace, looks something like this. And as you can see, it's got all your details and stuff. Please don't steal my details. But all you see here is the Launch Studio, and this brings you to the homepage of Machine Learning Studio. So the reason Azure Machine Learning Studio was created was essentially to give people in data and data science a one-stop place to go to. So this essentially features everything you really need to do any data science work. So that's the whole premise of this, and you can do collaboration and a lot of stuff with the whole studio, but we won't dive into that today. And you can see there's the notebooks, AutoML, and the Designer that I mentioned earlier. So when you think about data science or any machine learning problem anyway, there's two main things you need. You need a lot of data, and you need the actual machine to be able to do machine learning on. And all of that stuff is actually stored in one place. So you can go into your compute, and you can set up your computes from here, and you can manage them, turn them off, do whatever you'd like with them. From here. So there's a few different types, and I swear this is the most complicated it gets. There's compute instance. So this is whenever you're trying to do any machine heavy tasks, this is the kind of computing power it'll use. And to create the new ones, they're made the actual workflow really straightforward in terms of you pick a region, and it'll only show you the ones that you can actually access in terms of if you've only got specific capacity available on your subscription, those are the only ones it'll show you. You pick whichever one you'd like. It automatically picks a basic one, kind of the standard go-to one that most people use. And you hit next, and you just give it a name. And that's essentially all you have to do. And the same goes for a cluster. If you were doing any kind of batch training and things like that, this is just multiple different machines clustered into one that can do your work a lot quicker. It's the exact, sorry, my mouse is going a bit crazy, but it's the exact same process in terms of setting up this as well. It'll only show you the ones that you can actually access and create based on your subscription restrictions that you might have. And the only other one is the inference cluster. So these are the ones that are used to actually, so these are Kubernetes services is the easiest one to use. These are where if once you've deployed your model, this is how the power it'll use to actually maintain that as a live deployment. I swear that was the most complicated it was going to get. So that's the compute powers. And if you're confused about what one you need, or if you need to be creating all of them, don't worry, because when you actually start doing, and I'll show you this, when you actually start deploying your models, it'll actually tell you which one you need if you don't already have it created, and it'll guide you through the whole step process, not a problem. So those are your compute. So if you've got the machine sorted, we need data. You can connect whatever data store you'd like. You can connect it individually within your subscription. You can create them manually against different account keys and stuff, wherever you'd like. They're happy enough for you to bring your data from wherever. I'm just going to cancel that one here. Or if you wanted just a specific data set, you can actually create data sets from either a local file. If you've just got it sitting on your laptop, you can upload it directly here from web. If you know there's a link maybe on Kaggle or something that you wanted to use their data sets, you can import that directly within the studio itself. And open data sets. This is kind of my favorite thing on Azure Machine Learning Studio, just because if you're trying out the whole place for the first time, or you're trying to create a model, they've got all these data sets ready for you to use and implement into the product, and off you go. So I've basically pulled in the New York taxi data set. I don't know why it's kind of pushed into the corner a little bit, but let me just click into that so you can see. So this is the New York taxi data set. And you can literally call it whatever you'd like and pick the date range from what you don't want all your data. It's a really, really big data set. So just be a little bit careful. Maybe you only want a month of data for this to actually start training and testing out stuff. And that's it. Like, that will basically create a data set for you. I'm just going to leave that there. And it looks something like this. So it creates a data set. It has all your details for it. And off you go, basically. It's like ready to use, and it'll pop up in different places. So we've now got our machines and we've got our data connected up in different places. Let's actually create a model. So I mentioned AutoML, and AutoML, automated machine learning. I'm going to use this New York taxi data set, and I want to predict, like I said, I want to be able to predict what my tipping should be for a taxi trip around New York. So again, these are the data sets I've already created, but you can also create a data set again directly from here. So if you just wanted to dive straight into automated machine learning, you don't necessarily have to go through different steps beforehand. It actually guides you through the whole process. So you can connect from here, or like I've already got it, I'm just going to pull that one through. So I've selected my data set, and it'll basically tell me, okay, great. These are just the back-end things of where do you want this to sit? What do we want to name this experiment? So every time you run a machine learning model or anything like that, it's called an experiment here. And everything under that experiment gets grouped into one place and it stores it in that place. So you can create a new one, or you can select an existing one and pick a target column. This is what you want to be able to predict. So like I mentioned, there's a bunch of things here, but what I want to be able to predict is the tip amount. So I'll select my target column. And again, select your compute cluster. So for automated machine learning, you need a cluster compute. And if you didn't know that, that's not a problem at all, because you can actually create a new compute directly from here. So I'll just pick the one that's already been created. Sorry, let's create a new one. Let's call this test. And that's the third step. And so what kind of a task do you want to do? So machine learning can have a different variations, right? So you've got your classic classification kind of a problem where you've got a bunch of data and you want to be able to group it into specific things, whether it's green or blue or red. That could be a problem you might have. But what I want to be able to do is predict exactly how much tip I should have based on a few different factors. So that's going to be a prediction of a specific number. So I'm going to choose regression. And you can choose additional configuration settings and featureization stuff. But again, if you don't want to, not a problem at all. And that's it. You just click finish. So in about 3 clicks, I've basically been able to connect my data, create a compute store, and then make it go do machine learning on top of it. And I had to do no other work to do alongside it. So if I click finish, it'll actually start running this job. I'm going to cancel because I've already run it. It takes about 30 minutes to do it. So I'll show you one that I ran this morning. So this was the experiment that I ran this morning. It took 40 minutes to run this one. And you can see that this was a specific run. And what it does is then it picks out the best model and it gives you a summary of it. So it's told me that extreme random trees or the standard scale wrapper are the best ones. It's got correlation metrics, all these different things. But again, if I'm not a data scientist, I might be a New Yorker just living and wanting to know these things. Or, I mean, if you're a New Yorker, you probably know how to tip your taxi drivers, but maybe you're like me, or a tourist going to New York and wanting to know. You don't care about the details, you just want to see exactly what it's created. So you can pick your algorithm, so tell you this was the specific one, and then you can actually have a look at the explanation as to, okay, why is this the best? What's it actually doing? So to be able to predict a tip amount, the most important feature from the data is the total amount of your fare. I mean, that makes sense. Your tip makes up your total amount. The payment type apparently is really, really important according to this model that it's found it, and the fare amount. So if you've got $20 fare, the kind of payment it was, if you're putting it on the card, you might tip more. If you're paying in cash, you might be tipping less. So it is really important in terms of payment type. And then the total amount is a really big feature. So obviously, if you wanted to test different things, you could remove specific columns like total amount and run the model again. It takes that time out of you manually having to do this and just lets it run in the background while you can go do other things. So it saves you that kind of manual, time-heavy parts of machine learning. Great, okay, cool. I'm happy enough with the model as it is. I can have a few looks at metrics. I can pop in, so this just becomes a kind of visualization chart where you can pop whatever kind of metrics you'd like. You'd be able to see them. You can see histograms. And other than that, I think that's kind of all you really want to be seeing on this page. But once you were like, yep, I'm happy with this as it is, I can click deploy. And what deploying does is now reads to the compute type, which is a Kubernetes service. And you can pick whichever one. And this will deploy this model ready for you to use as whatever you'd like. And what it gives you, let me show you what an endpoint looks like, is something like this. So for the taxi, it takes a little bit of time, but it'll give you a REST endpoint. So if you're a developer and you just wanted to be able to add a little bit smarts to your application that you've built, you can do that. Use your data set, pop it up into automated machine learning, and for the one click, you create a REST endpoint that you can then copy and actually connect to, and it can use away against your application with no issues at all. I've never used REST APIs or connected them with applications, but from my developer friends that I've talked to, they say it's fairly straightforward. I won't say much more about that, but that's kind of from the machine learning parts of it. It doesn't take a lot of time or effort for you to actually get that going on the back end for you to be able to actually use it in wherever you might want to. So yeah, consuming, it just gives you that REST endpoint ready to go. So that's automated machine learning. With no coding or no machine learning knowledge needed, in about 5 or 6 clicks, I think it takes altogether, and about 40 minutes of your time, you've got a ready to go machine learning model. And it costs fairly minimal. So these target computes and stuff there, I think they cost about 30 cents an hour. So if your model is only taking about 40 minutes to load or to train up and stuff, and then deploy, your actual computing cost has been about 30 cents so far. Granted, if you're keeping your Kubernetes service going a lot longer, that might be a different cost, ongoing cost. But to get that set up and going, it only costs you 30 cents. And you didn't need to have a really big machine. You didn't need to have a really up-to-date 2020 MacBook Pro or anything like that. You could do this from wherever you'd like because it's all based in the cloud. That's that whole point of the democratizing AI, where it's available and ready to use for everyone at low cost. So that's automated machine learning. And the other low-code kind of a feature that I mentioned was Designer. So what Designer looks like is, as I mentioned, a drag and drop feature. There's a few demo ones that you can use. I'll just try and I'll show you actually what it looks like to create a brand new pipeline. So let's call this, as usual for every single demo, let's just call it test. I'm just going to pray to the gods that this actually works out on its own and I don't have to go through too much of a pain. So any data set that you've already created and registered it as a data set originally, those will pop up here, ready to be used. Or they've also got sample data sets. So I'm going to pull in the automobiles price data. So this is the sample data that I mentioned in the start. This is going to be the secondhand cars and what they look like. So I've got this data set here. And what do I want to do with it? I don't know much what sits in here. What does it look like? So I can actually have a quick look at what the data set looks like. And this is just an output of, these are the different columns it has, and it actually gives a histogram of each of the columns. So we've got the make of the cars, normalized losses. I'm not too sure what that column is off the top of my head. I'm like, okay, maybe I don't want to see that column when I actually run this model. The fuel type of the car, I'm like, yep, that seems kind of important to be able to guess how much the car is worth. Number of doors, the body style, so many different columns and details about every single car in this range. And then at the end is the price. And that's the price, is the current price that they've got mentioned for that car. So what I want to be able to do is, based on all these 25 different columns, be able to predict what the price should be. That will be my machine learning model here today. So I've got that. And the next thing I maybe want to do is actually, like I said, I saw that normalized losses and I didn't really like, I'm like, I don't know what that column is. I'm going to remove that column. So we can do that with the drag and drop tag. So we can edit our metadata. Let's pop that there, connect it to this. And this basically changes and edits your columns. So I want to include, actually, I want to include all my columns. Let's include them. And then I just want to exclude one of them. And I want to exclude a specific column. And that wants to be the normalized losses. I don't think that's going to be important into my model. So I'll remove that one. And once I've done that, the next step, as every data scientist will tell you, is cleaning your data. Cleaning your data is really, really important, as you only want to give the machine kind of what the bare minimums of what it actually needs to be able to use. You don't want to confuse it with extra data or incorrect data necessarily. So let's do clean missing. I want to be able to clean my missing data. Let's pull that in. Excuse me. And how do I want to do it? So clean my data across. I want to actually all my columns. I want to be able to do that on. And just for the sake of showing you all, please don't actually ever delete any data columns or rows like this. But just for the basis of it, I just want to replace. Let's say I can remove my entire row if there's a missing value somewhere, or I can replace with the mean, median, mode. There's a few different options that they've given you. Just for now, I'm just going to remove the entire row, please. I mean, I feel like the user might be watching. I swear I don't actually do this at work. I will never remove data that sits in live data. So once I've cleaned my data, I'm kind of like, yep, my model, I mean, the data set's pretty clean. I'm okay with this. It's ready to go. Again, machine learning, the next step is usually going to be splitting your data so that you can actually train it and then test it. It's kind of like teaching kids, right? So I mean, if you're in primary school, you're given a lot of stuff, you learn it, and then there's a test at the end of the day where you go test how much of it you've learned. Same principle applies here. So what we're going to do is split our data. Oops, sorry. Let's push that down here, connect that there. And maybe I want to split it 70%. So I'll give the machine 70% of my data to learn from, and then the rest of the 30%, I'll actually test them on it of how well did you do? Like, did you figure it out? How much should a car be priced at? We'll see. So 70% is all I want to split it to. Let's move this down a bit. And then I'd like to actually be able to train my model. If I can find my train model, there we go. I want to train it. So as you can see, the split data has two ends coming out of it. So the first one's going to be the 70%. That's the one I want to train. I say as it's got an error. I don't know why it's doing that for me. Let's just push that in again. Why are there errors? Oh, sorry, just wanted in there one. Okay, cool, that'll do. Right, so training my model, it kind of as, okay, I'll just delete this so I can show you that bit again. Oh God, okay. Yeah. When you try and drag it, it actually tells you what little holder it wants you to put it against. So it wants you to put it there specifically. So this is the data that you're sending to it. But when you're training a model, you actually need an algorithm to train it with. So that's what the first little bit is going to be. So you can choose specific different ones. It's got a bunch of different models you can use. So let me show you the different level, all the different ones it has. It's got a bunch of machine learning algorithms that you can use. But I mean, there's different things that you can always use. I'm just going to pull out the basic kind of a linear regression. Let's just start with that one. I'll pop that in, and that one's going to connect to here. And here, I want to actually tell it what model I want to be able to train it against. So I want to select a specific column, and that's going to be, as I said, we want to know what the price is when I predict it. So that's ready to go in training. Once I've trained the model, I need to actually score that model. And that scoring, what that essentially means is like, let me put it in. Okay, great. This is training. You've learned all that. And now let's test you against what it should be. So this is the testing data we pulled in and the trained data model. It's now figuring all these things out. So it'll score it, how well it's actually doing. Once it's on that, we'll give it an evaluation. So I want a full evaluation of the model of how well it did. So I can go into either of these, so let's pop it here. And that's basically it. I don't know why those things have popped up right now, but oh, okay, they're kind of disappearing on their own. That's a whole pipeline ready to go for you. And this applies to even really, really in-depth data scientists with PhDs who know exactly what they want to do. Because what this now means for you is I can just use drag and drops to really quickly test out maybe 5 or 6 different algorithms against my data on my 7% data and be like, okay, this is going to be the best one. And then actually go and start using notebooks to really dig deep into really parameterizing and tuning that model out to be the highest accuracy it can be. So once I'm there, all I have to do is hit submit, and this will go and start running it. So what I created one this morning, so I'll show you what that looks like. Once you hit submit, it shows you exactly what it did. It'll tell you all the steps have been completed. And you should be able to see the metrics. Okay, I'll pull those up in a different place and show you the actual how well it's done. But from here, you can, again, like I mentioned, the inference pipelines. So with the automated ML, we deployed our model to create an endpoint. It's the same step here. You can create a real-time inference pipeline. And what this does is it'll create, again, like we talked about, that endpoint ready for you to use as a REST API that you can connect to, and it stays real time. So whenever someone on your app is using that data or wants to get a prediction, automatically it'll run the model and give you a prediction. So once you deploy it, this is kind of what it looks like. So these models have then been registered in a model list. You can also find all your experiments in one place. I've tried a few different things around here. They're all ready and waiting for me. And then the endpoints, like I mentioned. So the designer cars created that endpoint. And once it loads, it'll show me the exact same kind of REST API ready for you to use and implement. You can actually, for anything using Designer at the moment, so they've implemented this functionality. They haven't done it for automated ML yet. But you can actually test exactly what this would look like on your apps. If you, on your app, have gone in and put all these details in of what the fuel type is, the car, it's a convertible, random details, you can ask it to actually test what your model would predict for this. So the price of the car was 13,000 and it's gone and predicted 22,000. Like, it's a little way off. But what if your machine learning model is telling you that this car is worth 22,000 and it's actually only being sold to you for 13,000? That's a bargain, but don't take the word for it yet. Obviously, go do a bit more detailed understanding of exactly how it works and just check all the details that you need to. But that's just a really kind of quick way of showing you exactly what it does in terms of when you reach for the web service and the API system. So that's Designer. It took a little bit more understanding of how machine learnings work, because you need to choose what kind of model you want to use, what algorithms you want to do, what your splits should be. So it's a lot more customizable in that sense than your automated ML. It's still really, really quick and fairly easy to set up. So that pipeline takes about 15, 20 minutes to actually run through and do all the training on. So let me just jump back into my slides. So I'm hoping you can see that now. Yep. So as a recap, my agenda for today was to show you a few features of using absolutely no code to create machine learning pipelines, which I think I did. I'm hoping someone somewhere out there got something out of this in terms of, hey, okay, cool, that looks pretty okay. I should be able to go do this if I wanted to. And just how easily in that one scenario, one studio setup, it enables everyone. So whether you're a data scientist, whether you're a doctor just wanting to, you have a bunch of data, you want to see if there's something you can predict out of it. Doesn't matter who you are, it's all in one place, ready for you to go, and supports everyone's capabilities and really guides you through quickly enough, but also it's not overwhelmingly like basic levels. But if you've forgotten to set up your compute, it's ready, it's already there, it's fine. You can create it when you're actually setting up your pipelines. It's all been built for everyone in mind, essentially. So that is my presentation. Thank you all for listening. I'm happy to take any questions that you might have. I actually have absolutely no idea if I've gone over or under my time at this stage. I can't see my timer anymore.
Hey, Akanksha. What an amazing presentation. Thanks a lot, actually. I think this complements perfectly, actually, our previous presentation from Martin, because actually what you're showing here actually is pretty much breaking down a little bit that machine learning complexity and allow people and businesses to start using machine learning easily, actually.
Yeah, I mean, as a business, you're not necessarily then reliant on the 2 data scientists you might have on your team, which have 100 different things they need to do, but you can actually just go do it yourself if you had to, and then get them to help you out with maybe really making it accurate and actually tuning it up a lot more. Just removes a lot of barriers overall, I think.
Yeah, I do have one question actually for you. What were some of the challenges that you found when learning about machine learning Designer?
Okay, honestly, it's the drag and drop. So I mean, it's still they're still working on it. It's the drag and drops. They've got a lot better now, especially I think I showed it where if you're trying to drag something, it tells you what little bracket to put it onto. That didn't exist at the start. So I remember when I was doing it, I was trying to drag things in and it just wouldn't work. It wouldn't connect to different things. And I'm like, but this is where it's meant to go. I don't know where else to put this. The other one that I had to put it on. Okay. There's a few things like that, but they're making a lot more improvements like that where they just highlight which one where you need to go. Or yeah, like the thing with Designer is you do need to know exactly what you want to do. So if you want to do linear regression, you'll know where it is to find. But then what if you don't even know if that's a feature that's available? Like, I mean, they've got all these different algorithms. You need to actually sit down and go through them a little bit. So that can be a bit daunting for some people.
Yeah, and that's a good point, actually, because I did have the opportunity to use Machine Learning Designer or previously Studio. And actually, the order of the components needs to follow a logical order, actually.
Yeah.
There is a specific order that you want to follow. And that's a good thing, actually, right?
Yeah.
And definitely that maybe requires a little bit of a learning curve, but still pretty much I think I found you can, is what I did actually, drag and drop and see, okay, I cannot actually connect that data set to this. I need to do this first, right?
It's a little bit of testing and trying, but it's kind of fun. I'm not gonna, I mean, it kind of brings you back to like a little school stuff where you're like, oh, let's test all this stuff out, see where it goes.
Yeah, definitely. Okay, for the attendees in the stream, if you have any questions, feel free to put them in the comments in YouTube. What's the best way for the attendees to contact you? Is your Twitter handle or?
Yeah, Twitter is definitely the easiest in terms. I mean, LinkedIn just gets spammed with recruiters all the time, even though I've told them not to. But I mean, if you reach out on LinkedIn, like, I mean, 90% of the time, I won't actually even see it. It just gets really bogged down. Twitter, definitely reach out on Twitter. I'm usually very active on Twitter. Yeah.
Okay, that's amazing. One more question, actually. What about working with large volumes of information? Will Machine Learning Designer be able to work with that?
I haven't tested that specifically, but it'll have no issues doing it because, again, the power it needs sits in the compute. And again, you can scale those up and down as big or small as you need those clusters to be. So it'll handle it. That's not an issue. It might take a little bit longer than you're used to for a smaller data set, but you can bump up your clusters and just add a few more machines against it. It'll do it really quickly. So then again, it comes down to how quickly do you want it and how much of a cost you want. But it shouldn't have any issues.
Yeah. One of your previous slides, you highlighted some of the challenges about adopting machine learning. One of those challenges, pretty much, you need to have the skills. You need to have people. What are your thoughts on where the Australian market stands right now within having skills available in the market? Do you believe that we already have many skills? We are short on skills or experts?
I feel like everyone will have a different point of view on this question. It's like one of those consulting answers of, well, it depends.
No, we want your point of view, actually.
Exactly. I think there's still demand. Like there will constantly be demand, especially in the current era we're living in with the pandemic. I mean, it's an unfortunate situation to be in, but people just don't have the budgets to pay for people to be doing the work. And AI and machine learning can really help in that. It'll automate a lot of more tasks for you. Like it's a booming industry, especially now moving forward. It's not necessarily that jobs are being taken away. They're just being replaced with a different type of job, which is creating machine learning models that can help reduce effort for businesses. And so I think the market is getting a lot bigger and it's getting a lot more notice than it did maybe even a couple of years ago. And as many people are entering into it, it's one of those things. It's a double-sided sword, right? I mean, it's like, it's machine learning is really easy to do now with all these different products like this, where it's zero code, but it's still a lot of responsibility that goes with it of making sure your models aren't biased or they're responsible models. So yeah, skills kind of can be really easy at times to pick up, or if you're using zero code solutions like this, you're ready to go in a day. Like that's all you really need to train yourself. But to actually understand what you're doing with your data and those kind of skills are a lot harder to get. So that experience is still needed. So yeah, I think it's a lot more demand ready to be used in Australia, I think.
Yeah, that's a good point, actually. Yeah, that's a good point. You just mentioned experience, right? So even for people who are starting right now with machine learning or AI, actually, if they look forward in 2 or 3 years, they're going to have experience. I think that experience that is going to be highly demanded in this market.
Yeah. I mean, even if it's just you doing random things in your free time, like if it's just setting up a random pipeline like this, you'll start noticing even just smaller things. You're like, I wouldn't have known that. Picked it up, off you keep it going. Like, especially as in from my point of view, like I work in consulting, every client that I would work with is completely different context in a completely different industry. So coming into those is like, okay, I now have to take a step back and try and understand their data and their context for why they're trying to do this or why they're trying to put machine learning or smarts behind it. And that honestly, no matter how many skills you have, and this is coming from like our lead data scientists at work too, it takes time to build that skill of understanding really quickly what the context of your data is. And that's a valuable skill to have. So if you're just even if you go on Kaggle, try a few different projects, knowing the different intricacies of different data sets, that's really, really valuable. I mean, I'd really recommend that.
Yeah, definitely. Okay, thanks a lot for getting involved. Thanks again. All the work that you're doing for the community is great. Please keep doing the same. I'm looking forward.
Yeah. If there's a place for low code talks to be done, I am all about it. I want everyone to be doing machine learning at this stage.
Okay. Cool. So thanks a lot for the attendees in the YouTube channel. Please go on to the webpage and start submitting feedback for the different presentations. Thanks a lot, Akanksha. We're looking forward to having you in a different event in the upcoming months. And yeah, have a good weekend, actually.
Oh, thank you. I will actually. Got the sun shining down. We'll cry with some hay fever outside. It'll be great.
Okay, take care. Bye.